Hello, everyone. My name is Kaylee, and I will be presenting on the AI-based skincare detection for the IGSRC conference. So how did we define this problem? So in the US, the prevalence of melanoma, one of the deadliest types of skin cancer, has more than doubled in the past 30 years, which is a fairly staggering number. This makes early detection so crucial, as the 5-year survival rate is 99% when melanoma is detected early. But unfortunately, many people ignore the early signs of skin changes due to limited access to medical resources and concerns about privacy. So the aim of this research project is to leverage mobile application development, including Android and iOS, for the early detection and monitoring of skin cancer. So how can we develop a free and reliable AI-based app to detect early signs of skin cancer? So just imagine being able to simply take a picture of a mole and sending it to a AI dermatologist for free and reliable diagnosis using a CNN, which is a convolutional neural network. This has been trained on more than tens of thousands of images, and by using this predictive model based on computer-aided diagnosis and implementing a CNN to classify several different types of skin cancer using these lesion images. So this is Mr. Bean, and he wakes up one day and notices a fairly large mole on his face. So he's a little worried, so he takes out his phone and opens the skin cancer detection app. He takes a picture, and the CNN is able to scan the image and process it in relation to those thousands of images in the dataset. And this ultimately outputs a conclusion, and we see Mr. Bean fairly happy, so the app must have detected no cancer in his mole. So using this theoretical framework, we hope to significantly improve the usability and detection accuracy of the model. And these findings have the potential of making a positive impact on the lives of millions of people. So, AI-based skincare detection has become increasingly popular due to its potential of improving early diagnosis and treatment, but there are benefits and significant limitations associated with this technology. So, some benefits include improved accuracy, faster diagnosis, accessibility, and it being fairly cost effective, which it's almost free to use. So some limitations include lack of diversity in the training data. So even though it's trained on thousands of images, there is a possibility that the AI encounters something that it's never seen before. Limited sensitivity, reliance on image quality, and lack of transparency. So commonly used AI models for skincare detection include, which includes skin lesions, are CNNs, which are a type of neural network that can automatically learn and extract features from an image. SVNs support vector machines, which are a type of machine learning algorithm that can be used for binary classification problems. Random forest, which is an ensemble learning algorithm that combines multiple decision trees to make a prediction, which has been used for high-dimensional data as it is resistant to overfitting. So next is deep learning, which is a subset of machine learning that involves training artificial neural networks with multiple layers. And k-nearest neighbors, KNN, which is a simple algorithm that can be used for the classification and regression problems based on their visual characteristics. So some existing examples of apps for skincare detection are Skin Vision, which uses machine learning to analyze photos of skin lesions, and then it provides a risk assessment and recommendation for further action, which may include visiting a dermatologist. Derm Engine, which is cloud-based dermatology. It's a software platform that uses skincare detection and AI to provide a risk assessment. similar to skin vision. So next is First Check, which is a little different. It's a telemedicine platform that includes the skin detection characteristic and allows users to take photos of skin lesions and receive a diagnosis from a dermatologist within 24 hours, which is a pretty fast turnaround. And then lastly is My Skin, which is a skin monitoring app that allows users to track changes in their moles and other skin lesions over time. So they also use AI algorithms to analyze these photos and provide a risk assessment. And I would like to mention that these apps are paid services and patients may or may not get the instant results. So the detection results vary on the base of the algorithms and the data sets used to train the model. So next is the conceptual, sorry. There we go. Next is the conceptual research framework. So so this is part of our methodology, and we in our previous research we did a comparative study of ensemble deep learning models for this skincare detection, and it turned out that the ensemble CNN models performed better than the SVM shown on the data table on the left, and then on the right is a diagram of our conceptual framework going through it step by step. So next is methodology. So we first had to understand the current ensemble CNN model, its architecture and how it works, which this will help identify the parts of the model that can be reduced in size to make it lightweight. Next is identifying the platform limitations. So Android and iOS platforms have limitations in terms of memory processing power and storage. So it's important to identify these limitations and design the model accordingly. Next is reducing the size of the model. So based on understanding of the model and the platform limitations, the size of the model needs to be reduced, which can be done by removing unnecessary layers, reducing the number of filters, or using a small kernel size. So next, we had to test the model. The reduced model needs to be tested, ensure that it still performs well in the terms of accuracy and speed, which can be done by using a validation dataset. Next is developing an API. So once the model is tested, an API needs to be developed using the MIT Apps Inventor, which will be used in Android and iOS applications. So then we had to integrate the API, which will enable the applications to use lightweight model for inference. Next is evaluating the performance. So after integration, the performance needs to be evaluated to ensure that it works as expected and meets the desired accuracy and speed requirements. So next is datasets. So the datasets that we use to train the machine learning algorithms in this project included a large number of images of skin lesions along with accompanying clinical data such as biopsy results, diagnoses, and other patient information. So these datasets may be sourced from public databases such as the International Skin Imaging Collaboration dataset, or may be compiled with private medical practices and research institutions. So, and it's also worth noting that the quality and diversity of the dataset used to train machine learning algorithms can have a significant impact on the accuracy and reliability. So a more diverse dataset that includes a variety of skin types and lesions can lead to a more robust algorithm that performs well in real-world scenarios. So our study targeted the publicly available skin lesion image sets. So images found on the internet and collected using the clinical data. So again, our CNN network classifies 7 different types of skin cancer from outlier lesion images. So, and 5 of them are shown below. So, including melanoma, benign keratosis-like lesions, melanocytic nevi, and others. So, for the preliminary results, we use MIT Apps Inventor to develop API as no AI models have been linked to this API yet. And for future work, in the last few years, there have been a lot of interest in making models smaller for resource-efficient training and interference on IoT devices. And to better facilitate our detection apps, we plan to explore 2 main approaches. So the first and most popular is to train neural networks that are lightweight by design. And this compression maintains reasonable performance and is achieved by the introduction of depth-wise convolution layers, which help to reduce model size and complexity. The other approach is to leverage large pre-trained neural networks and compress them to reduce their size while minimizing loss in performance. So this article will focus on reviewing and implementing some of these compression techniques on convolutional neural networks, which is CNNs. So thank you for listening. I hope you learned something new, and feel free to contact me with any questions you might have pertaining to this research project. And yeah, thank you for listening.